This lecture is on solving a system of linear equations using the substitution method. So let's write down the method and hopefully you won't forget it. So the steps involved is, first you need to isolate a variable from one of the equations. So choose one of the equations and isolate one variable. Okay, so most of the time the variables are x and y. So basically what that means is you have to either get x alone or you have to get y alone. Okay, so you have to isolate one variable. And the next step, what you need to do is to substitute the result into the other equation. So that's crucial. Make sure you put into the other equation. Okay, so you cannot put back into the same equation you got from. And then what you need to do is to solve that equation. And when you're done, step 3 is asking you to continue to find the solution to the system. But remember what that means. The solution is always made up of an ordered pair. You will need to give me two numbers. Okay, so an ordered pair is made up of two numbers in our case, and we need them as coordinates. Okay, so let's look at the first example. Supposedly you are asked to solve and say the system is y minus 1.2x equals 0.4, and the other equation is 6y minus 5x equal 9. So in front of you there's two equations. The trick is to look for a variable that is by itself already, like this. So from the first equation I'm going to isolate the variable, so it's going to read y equal 1.2x plus 0.4. Okay, so that's my result right there. And what I want to do is to put the result into the other equation, and in particular I'm putting into the place of y. So where y is, substitute that in. Okay, so it's going to read 6 times of, in place of y, you will replace it by 1.2x plus 0.4 minus 5x equal 9. So all we're replacing is just the y portion right there. Okay, so the y has been replaced to 1.2x plus 0.4, like that. Okay, now we have this new equation that is only made up of one variable. And all you have to do now is to distribute. So 1.2 times 6, it comes out to be 7.2x plus 6 times 0.4 is 2.4 minus 5x equals 9. If you combine like terms, 7.2x minus 5x is 2.2x plus 2.4 equal 9. So 2.2x is equals to 9 minus 2.4, which means 2.2x is equal to 6.6. So if we divide both sides by 2.2, what's going to happen is x equals 3. But remember, for you to say it's a solution, you need to have two numbers. It's the x followed by the y. Okay, so what we found is only x, so put the number in the first spot. And to find the second number right there, you have to use the equation. And I'm going to choose my resulting equation, which says y equals 1.2x plus 0.4. And since x is 3, that means I need to multiply 1.2 times 3, which comes to 3.6 plus 0.4, and that makes it 4. Okay, so that's how we say the solution is 3, 4. Sometimes the equations, all the variables are squeezed to one side. For example, in example 2, x plus y minus 7 equals 0, and 5x plus 12y minus 7 equals 0. So what you have to do is pick a variable to isolate, and since x is alone and so is y, so let's try x, for example. So x is equal to negative y plus 7. So what I just did was to move all the other terms to the other side of the equal sign, leaving x alone. Okay, so this becomes my result. And what I'm doing is I'm going to put the result into the other equation, and in particular I'm substituting into where x used to be. So it's going to be reading 5 times of, in place of x, it's now going to read minus y plus 7. Okay, but there's other terms, so continue writing is going to be plus 12y minus 7 equals 0. So all that has changed is the x has now been replaced by negative y plus 7. Okay, so now that I have an equation in one variable, I'm going to distribute, which gives it negative 5y plus 35 plus 12y minus 7 equal 0. If I combine like terms, negative 5y plus 12y is 7y, and 35 minus 7 makes it 28 positive. So bring the number to the other side of the equal sign makes it negative 28, and when I divide by 7 both sides, tells me y is negative 4. So this is just to remind me that the solution is made up of two numbers, and this time because the number we found was for y, it sits in the second position. And so for me to find the first position, I need to use one of the equations. I'm going to choose my resulting equation, which says x equals negative y plus 7. Okay, the one in the box. And I'm replacing the y by negative 4. Watch out, all you're replacing is just a y, so this minus actually stays. Okay, so it's going to be negative 4 plus 7, which makes it positive 4 plus 7, and that makes it 11. So the solution is going to be 11 comma negative 4. So if you recall, a system of equation basically is looking for the point where they meet. Okay, and so this coordinates 11 comma negative 4 is where the two lines meet on a graph. Now let's consider example 3. Again, we're asking you to solve, and the system given to you is x equal 4 minus y and 4x plus 4y equal 16. Now in this question, you notice that the first equation is already nicely isolated for you, so that straight away becomes my result, and I'm going to put this resulting into the second equation where the x used to be. So it's going to read 4 times of, in place of x, it's going to read 4 minus y plus 4y equals 16. Now, same thing, I'm going to distribute. It's going to read 16 minus 4y plus 4y equals 16. The strange thing about this is you notice the variables cancel. Okay, and in its place, I end up with 16 equals 16. So what I was telling you in class is when the numbers match, it means the two lines are coincident lines. That means they're actually on top of each other. So there are infinitely many solutions. So the type of lines that you will see is what you call coincident lines, meaning if you were to draw them on a graph, they are right on top of each other. And being right on top of each other, that means they pretty much meet everywhere on the line. And if they meet everywhere on the line, there is infinitely many of them. Okay, let's look at example 4. Supposedly you're asked this time to solve 1.5x minus y equal 1, 6x equal 4y plus 7. So I'm still looking at the first equation because I see the y by itself, and I need to get y alone. So it's going to read negative y equal negative 1.5x plus 1. But I cannot have negative y, so I'm going to divide everybody by negative 1, which makes it y equal positive 1.5x minus 1. So that becomes my result. And I'm going to use that result into the other equation where y used to be. And so it's going to read 6x equal 4 times of. In place of y, I'm now going to put in 1.5x minus 1 plus 7. Okay, so what's going to happen now when I distribute is 4 times 1.5x is 6x, and 4 times minus 1 is negative 4. So when I bring the 6x to the same side, what's going to happen is I end up with 0 on one side and 3 on the other side. So this time, unlike the earlier example, the numbers don't match. So when numbers don't match, okay, this means that the two lines are parallel lines. So if you are looking for point of intersection but the lines are parallel, that's when we say that the system has no solution because there is no point of meeting. In summary, you will notice there are 3 types of systems. First type is where we say that they are consistent, and basically they are made up of intersecting lines. And you notice because the lines are intersecting, you will notice that you will end up with only one solution point. And the solution always ends up with an ordered pair, something like that. Okay. Now the other type that we saw as in example 3 was where we actually saw the dependent system. And what dependent system is made up of is they are made up of coincident lines. So they are basically the same lines. So when they're same lines, you'll notice that there's infinitely many solutions because they meet everywhere on the 2 lines. So this was seen in the example 1 and 2, and this was seen in example 3. And in example 4, I was showing you the 4th type, which we call inconsistent. And this is made up of parallel lines. And for this kind, there are no solutions.